Good afternoon, everyone. Welcome to our talk. My name is Ian Botsford,
I'm Todd.
and we work at AWS. We're here today to talk about generating Kotlin SDKs with Smithy. So the first logical question is, what is Smithy? Well, Smithy is a toolkit for building services and clients, also called SDKs. It's used extensively at Amazon and at AWS to build our own web services, and it's an open source product, so it's available for anyone in the world to use to build their services as well. Smithy has its own interface definition language, or IDL. The IDL defines a service, its operations, and its capabilities, and we refer to this as the model. Everything in Smithy revolves around the model. It's a key part of the API review process in that models are declarative code that can be reviewed and diffed and checked into source control just like any other kind of code. Models can be validated against best practices and API standards. Models can be transformed and processed to either build them up or to filter them down for specific use cases or contexts. But by far one of the most powerful features of models in Smithy is their use in code generation. Many of the primary design decisions of Smithy are built around code generation as a first-class feature. So today in our talk, we're going to go over a little bit of a history of Smithy's origins to help frame why it exists and what kind of problems it was designed to solve. We're going to give a quick tour of Smithy's features and capabilities. Then we're going to dive into a live demo where we use a model to generate some Kotlin code and then write a demo application against it. And then we're going to wrap up with a short discussion about what the future holds in store for Smithy and Kotlin, and hopefully leave some time for Q&A. So why does Smithy exist? Well, at Amazon, we've been building web services internally for a really long time. And in the early 2000s, we started developing in-house frameworks to bring some structure to that process. In 2006, the first AWS services were launched, and they were built on these early frameworks. As a few more years went by and a few more AWS services were launched, we started to discover that each of our frameworks had unique strengths and weaknesses that made them better or worse suited for certain applications. None of our service frameworks were built with externally facing web services in mind, and they had these huge trade-offs that teams had to make at the outset of their new projects before even a single line of code was written. So in the years that in 2008, we launched a new service framework to try to gather the best features of the previous ones under one roof. It was model-based, it was protocol agnostic, and it was designed with both server-side and client-side code gen in mind. This new service framework allowed us to accelerate the process of developing web services at Amazon, as we went from just 3 AWS services in 2006 to over 375 today, and tens of thousands of internal-only web services. In 2010, AWS launched its first SDK for .NET, and in the years that followed, it released several more SDKs and tools and hundreds more web services. But at this point, we started running into problems. The scale of that growth exposed some gaps in our API best practices. And our customers, both internal and external, told us about jarring differences and painful scenarios when using multiple services or multiple languages. So in 2016, we tried to codify and improve the API standards across AWS. With those higher standards came a renewed focus on modeling correctness and consistency. The existing framework that we had lacked some of the powerful features necessary for larger and more complex services, such as meta-modeling or linting. So in 2018, we launched Smithy. It became rapidly the recommended way to develop new services and new clients at Amazon. It was also our first open source framework that we developed to allow non-Amazon users to build their own web services using the features and the knowledge that had already been proven out at Amazon scale. Going forward, all new AWS services and clients are built on Smithy, including the 3 newest SDKs for Rust, Swift, and Kotlin. The kinds of problems that Smithy was designed to solve are not unique to Amazon. Any business that has organizational units that operate independently but need to communicate we'll have to coordinate that communication in terms of what protocols to use, what serialization formats to use, how error handling works, how APIs are allowed to evolve, and so forth. The problems become even more challenging when you have multiple ecosystems or multiple languages in play. Then synchronizing details about data representation over the wire or error handling semantics become even more critical. So with that, I'm going to hand it over to Aaron for a quick tour of Smithy.
Thanks, Ian. So now that we understand a bit about why history exists and its motivations, let's take a look at what it actually looks like in practice. The easiest way to learn about Smithy's modeling capabilities and the IDL is to dive into an example. So today we're going to be building a new service using Smithy, the Elastic Leaderboard service, which we'll use to manage leaderboards and high scores for an online gaming platform. We're going to take a look at some of the different IDL features, and then we're going to build on this model in a live demo. But let's take apart what we see on screen here first and go through it line by line. So first we give the IDL version that we're using. This just tells Smithy how to parse the file. Next we give the file a namespace. Every shape in Smithy belongs to a namespace. Here we have some use statements. This allows for us to refer to shapes from another namespace using an unqualified name. It's very similar to like a Kotlin import statement. And here we have our service shape, which we define using the service keyword. The service shape is kind of the entry point to an API. It's what both client and server codegen are going to use to start with and traverse the graph of shapes that are reachable from it to figure out what code to generate. This service defines a single resource, leaderboard. Resources, we're going to talk more about them in a minute, but you can basically just think of them as an entity with a unique ID and a set of lifecycle operations defined over it. Here we have a documentation comment. A triple slash is a special type of comment in Smithy that basically is going to attach that documentation to the shape that comes immediately after it. And finally, we're applying a trait to a service. Traits are Smithy's way to extend and constrain a model, and we're going to talk more about them again in a minute. But this trait is just a protocol definition trait. So it tells Smithy how to do a bunch of things, like how to serialize the shapes, so whether we're using JSON or XML, which transport to use, so that could be HTTP, MQTT, or something else. It's how errors are represented and propagated, as well as the set of traits that the service needs to understand. And so Smithy's protocol agnostic by default. It doesn't come with a default protocol, and you can bring your own. In fact, a service may support more than one protocol. So we've seen the service shape. Let's take a quick look at the other possible shapes we'll see in Smithy's IDL. We know that a service can have 0 or more resources, and both a service and a resource shape can contain 0 or more operations, which is the functionality that we want to invoke. An operation consists of the input, the output or return type, and the set of possible errors that we might see when invoking it. All of these, the input, output, and errors, are going to be a structure shape in Smithy. And the structure shape is one of Smithy's aggregate types, basically a type that can contain other shapes. You'll find a few common other aggregate types to represent collection shapes like lists and maps or discriminated unions. And finally, we have the set of simple shapes. These are things that you're going to be familiar with, like integers, booleans, strings, etc. And all of these types, so the simple shapes, can be a member of one of the aggregate types. So you could have, of course, a list of strings or a structure with different members of different types. And finally, an aggregate type can contain other aggregate types. So you can have a list of structures or a structure with nested structures and so on and so forth. All right, let's take a second to talk about traits. Traits are a way to extend or constrain a model by augmenting shapes to provide additional context. Under the hood, traits are just defined in Smithy's IDL. And what that means is that you can actually define your own custom traits to provide whatever kind of validation, linting, to extend code gen, whatever you need to fit your domain. And we use this all the time at Amazon and AWS. We're not going to have time today to talk about how to define your own custom trait and provide those kind of custom backing implementations and logic. But I think it's important to know that all the traits we see here today is something that you could write. You're not limited to what Smithy provides. Of course, you don't have to reach for building your own trait out of the box. Smithy comes with a lot of common traits that you might hope for, things like marking members as required, providing defaults, or marking errors as retriable. Smithy's a lot more than just an IDL for defining services, though. It comes with a set of build tooling for building and querying models, and even diffing them. So you can take a version of a model, make some updates to it, and Smithy can summarize the changes and even validate that they're backwards compatible. And so Smithy provides a validation and linting framework that you can hook into, and you can use that to enforce API standards and best practices. And finally, Smithy provides a way to transform models. So you can take one version of a model and, say, export it to a different format, like OpenAPI, or you can do simple things like just filtering shapes. So you might do that if you were, let's say you had an internal-only version of a model and you wanted to provide a public version. Well, before you do that, you might filter out operations and shapes that are internal-only. All right. With that brief introduction to the IDL, let's jump over to a demo. So before we jump into the model, I just want to give a brief overview of what we're looking at. So we've got a project set up here, a Bootstrap project. This just is going to take Smithy's Gradle plugin and our Smithy Kotlin code generator to process the model and then output the code. So you're going to see me run a Bootstrap task a few times. That Bootstrap task is going to basically dump all of that generated code into this project here, this leaderboard client SDK. You can see right now there's nothing in it. So let's hop back over to our model and start building it out. So we've got the same model we were looking at, the Elastic Leaderboard Service, with a single resource. I've got a bunch of to-dos in here for us to go ahead and fill out together. So let's start by defining that resource. So we say resource leaderboard. And I mentioned earlier that a resource needs a unique ID, so we're going to go ahead and add an identifier to this. So we'll say ID, leaderboard, ID. We'll add a new shape for that. We'll say string, leaderboard ID. I'm going to apply a trait to this. I'm going to say that leaderboard IDs need to be least min of 4 and a max of, say, 64. Next, we're going to add some common properties that we expect a resource to have. So we're going to say that a resource has common properties like a name, which will make a string, and the maximum number of scores that the leaderboard can contain. We'll say max entries. We're going to add a new type for that as well. So we'll make that an integer, max entries. And I'm going to apply a trait to this to constrain it as well. So we'll say range needs to be at least 1, and we'll say max 32. You'll note I used Smithy's built-in string shape here, but I defined new primitive types for these. The reason I did that, the reason you might do that in your models, is to provide this additional context here, to apply different traits to it and constrain the model further. All right, with that, let's go ahead and add our first operation. So we need a way to create a leaderboard. So let's add the create operation to this resource. So we'll say create leaderboard, and we'll come down and define a new operation. All right, where were we? We're creating a leaderboard. All right, the first thing we need to do is we're creating a new operation, and we are using the REST JSON1 protocol. This is a HTTP-based protocol that binds to JSON documents. So we need to give this operation HTTP semantics. So we'll do that by pulling in a new trait, the HTTP trait, and we're going to say this is going to be a post request to /leaderboards. Next, we need to give the input and output types to this. So we'll say input, create leaderboard input, output, create leaderboard output, and errors. We'll just go ahead and use one of the validation errors that we can pull from Smithy. So we'll say validation exception. Okay, last thing I'm going to do is add some documentation to this, create a new leaderboard. All right, let's go ahead and define our input and output structures. So we'll do that by saying structure, create leaderboard input, And we'll go ahead and copy and paste this and create the output. All right, leaderboard output. We know that our leaderboards need a name and max entries, so let's go ahead and add those. So we'll say name, string. We'll mark this as required, because we know we need it. For the max entries or the max high scores we're going to store, we'll default it those. So we'll say max entries, subtype max entries, and we will write that as a default. If a user doesn't supply it, we'll just default it to 10. All right, in our output, we know that our resource is identified by an ID, so we're going to go ahead and assume the server is going to return to us an ID for the leaderboard. So we'll say ID leaderboard ID, and we'll make that required as well. All right, there's two more things that I want to add to this. I want to add the input trait to this and the output trait. So we said traits can be used to extend or constrain the model. These two traits, all they do is constrain the model to say that this input and output structure can only be used now as the input or output of an operation, specifically a single operation. And the reason for that is if you had multiple operations and you were reusing these types somewhere, either on the input or output or nested somewhere else, it might be really hard to evolve your model later in the way that you want to. So this constrains it to say you can only now use it in a single spot. The last thing I want to do is to make this an idempotent operation. So let's say we were creating a leaderboard and our connections drop before we get a response or something like that. We want to go ahead and make it an idempotent operation. So we'll add a new token field and we'll mark it as idempotent. The idempotency token trait. This tells servers they're going to have to handle this kind of deduplication, where if they see multiple tokens in a row over, say, some time span, they need to deduplicate the request. It's going to tell client generators that they need to go ahead and fill this in if a user doesn't specify it. And with that, I think we have enough to actually generate some code. So let's go to our Gradle task to generate some code. All right. We've now got some code dumped into this project. We're not going to go over all these packages. We've got some auth packages. We don't have any auth on our model. We have some endpoint-related things. We do have our generated types, so our request types, our exceptions and things. We have generated serialization and deserialization to bind it to HTTP semantics and deal with JSON serialization and deserialization. But let's go ahead and just pull open the generated client. So Smithy Kotlin generated a Elastic Leaderboard client interface here. We've got a bunch of stuff for how to construct the client and configure it. I don't think we're going to have time to dive into that. Let's scroll down, though, and we'll see that we now have a suspend create leaderboard operation on this interface, and we've got our input and output types. These are named slightly differently. That's just the Smithy Kotlin code generator applying some normalization across the input and output types. But if we take a look at them, they should look like what we expect. We've got a name, string, token, and our max entries. If we look at the output, we should have our required ID. Let's hop back over to our model. We're going to go ahead and we've got a way to create them, so let's go ahead and provide a way to list or enumerate our leaderboards now. So we'll add a new operation, list leaderboards, and we need to find a new operation for that. So scroll down here, we'll say operation list leaderboards. We know this is HTTP, so this time we know we'll go ahead and bind it to an HTTP GET to also /leaderboards. Because we're using HTTP and using HTTP GET, Smithy has built-in validation for this trait that understands that this should probably be a read-only trait because you shouldn't be modifying any, or this should be a read-only operation. You shouldn't be modifying state on the server, and it's going to tell us we should really apply the read-only trait. So I'm going to go ahead and do that. We know we want to return a list of leaderboards, so I'm going to define the output to do that. So we'll add a new output shape with leaderboards, and we'll say leaderboard summary list. This is a new list shape that we're going to add. List, leaderboard, summary list, and this has a type or member of leaderboard summary. All right. We need a new structure shape, so we'll say structure, leaderboard summary. And we need to associate this with our resource, And we know that a resource has an ID, a name, and max entries. A couple things to quickly call out. Before on the create operation, I explicitly defined these structure shapes like this. You can also use just some of the syntactic sugar, thank you, Ian, to define these inline in the operation itself. So these are equivalent to just defining those same things externally. The other thing is these down here are just shorthand for also writing these out explicitly like this. So those mean the same thing. All right. We've got a way to list these. One last thing I want to do. What if, this is the Elastic Leaderboard service, right? So let's assume we're going to deal with millions or enough leaderboards that they might not fit into memory. So a common way of dealing with that is to paginate over the results. Smithy provides built-in pagination support, specifically cursor-based pagination. So that's where the server returns to you a token or a cursor, and you can use that when you have a truncated result set to fetch the next set of results until the server doesn't return to you another token. So let's go ahead and do that. We'll add a token to our output, say next token string, and we will add an input now to do that. So we'll say next token, also string, and then we'll define the max number of entries or that we want to define here, so, or max results, I think is what it should be. Max results. And that'll just be an integer. And then to make this paginated, we'll add another trait. We'll say at paginated. So input token is bound to the input member, next token. The output token is bound to the output member, next token. And our page size is max results. So these here are just binding these to the input member, next token, the output member, next token, and the max page size. And Smithy will validate if we have a member here named that doesn't exist. All right, with that, let's go ahead and generate some code. We'll bootstrap our code again. We got an error. This says, found documentation comment.
Further up.
We have a bunch of stuff I'm going to get rid of down here. Let's run that one more time. Still got an error. All right, this operation uses the get method in the HTTP trade, but the following members are sent as part of the payload: max results and next token. So what Smithy's telling us here is that there's some validation for this HTTP trade, and that we're using an HTTP get, and that we have bound these members implicitly to the payload. And sending a payload with an HTTP get is usually not what you want. It's not well supported by clients and servers, and so it's trying to enforce well-defined HTTP semantics for us. And so we can go ahead and fix this by moving these to query parameters instead. So we'll say this is going to be bound to the HTTP query member, next token, and we'll do the same thing here. So we'll max results, it's going to be bound to the HTTP query, max results. All right, let's try one last time. All right, great. Let's take a look at our output. We have a new function on here, list leaderboards. And we have a new package, paginators. So in Smithy Kotlin, we turn pagination into an extension method on the client that has the same name as the operation with the paginated suffix. So we have list leaderboards paginated. And instead of returning a single result, now we get a flow of the response type. And internally, this flow is going to handle that back and forth with the server. As next tokens are returned and we collect more on the flow, we'll go ahead and request another result or another response behind the scenes. All right, I'm not going to handwrite out all of these, but we need to finish out our model here. So we're missing operations to read, update, and delete a leaderboard, but we also need a way to associate scores with a leaderboard. So let's go ahead and add those operations. I'm going to just copy and paste them in from file here, and we'll talk about them here in just a sec. All right, so we've got our delete leaderboard operation, our update leaderboard, and get to get detailed information as well as the high scores. And then we've got a new operation here, submit score event. This takes in the ID of the leaderboard. This gets hoisted to the URI, so we've got a placeholder here for that member name. And then we've got a score event. And we've defined score event as just the user that achieved that score and an integer game score here. The last thing to call out probably is that we've defined a new error type ourselves, and we do that by adding the error trait. And specifically, this is a client-side error. So if we've supplied, say, like a leaderboard ID that doesn't exist, we're going to get back a not found error, and we're tying this to the HTTP error semantics of an HTTP 404. Okay, in just under 200 lines of code, we've got everything we need to create and manage leaderboards. I think I do need to associate these with the resource still. So let's go back up to our resource and add them. So read is going to be tied to get leaderboard, update leaderboard, delete. These are all the methods that a Smithy resource understands out of the box. They're your standard CRUD, create, read, update, delete, and list. But you can associate other operations that are not known to Smithy, like our submit score event. Let's go ahead and bootstrap one last time. Bootstrap. And we'll take a look at our output. And now we have all of our operations. So create, update, delete, list, and submit score event. With that, I'm going to hand it back off to Ian, and he's going to walk you through actually using this client to talk to a demo server that we put together.
All right, thanks, Aaron. So I'm going to close all this. And I'm going to make sure my server is still running. It's not. I think it went out of the building with the rest of us. Okay, now it is. All right, so now that Aaron has bootstrapped a client SDK for us, we can use it in a demo application to achieve something akin to what you might do for business logic. So the first thing to do is to instantiate a new leaderboard client. We're going to do Elastic Leaderboard Client. The Smithy Kotlin generator provides DSL builders for almost every type of object that it generates. So we'll use this DSL builder to specify the specific endpoint that we want to hit for when we're making these calls. And we'll just use a static endpoint that is this service running on my local machine. The other thing we'll do is that we'll wrap our usage of this in a use statement. This ensures that we close the client cleanly after we're done with it, and we don't leave any resources dangling out there, such as threads or the HTTP engine. Okay, so we've got our client created. Now let's use it to create a leaderboard. So we'll create a leaderboard. We know that name is required, so we'll say KotlinConf 2024 is the name of our leaderboard. I'm going to override the default for max entries by specifying something else like 20. One more thing, because the create leaderboard operation returns an ID, I think we're going to want to use that ID in subsequent API calls. So I'm going to save that leaderboard ID in a local variable by getting the ID member of the response. So now we'll have that available. And we'll print out to the console, created leaderboard ID. Okay, the next thing we'll do is we'll use the client to list our leaderboards. And then for the response, the leaderboard's member, we can iterate over each of those and just print, we'll just print the object itself. All right, so we've got enough code here to do something interesting. Let's run this and see how it works. Since this is the first time we're building with this client, it may take a second for Gradle to find all the necessary dependencies. All right, so we created a leaderboard. It got assigned the ID leaderboard-0. When we listed the leaderboards, the only one that exists is the one that we just created, which is not surprising since I just restarted my server. Next, we'll come back to this code and we'll run it again, but we'll update the name so that the name for the leaderboard is unique and it's easier to understand. But after listing them, let's actually submit high scores to one of these leaderboards. Client.submit score event. The leaderboard ID, or the ID is leaderboard ID. And then we'll use another DSL, like a sub DSL inside the operation invoker to specify the score event. So score we'll say is 25, the user is me. And let's submit a couple of these high scores so that we have something interesting to look at in the leaderboard summary. So we'll say that a second user scored 35, and we'll name him Aaron. The last thing that we'll do then is we'll use the client to get the leaderboard summary. So get leaderboard for ID equals leaderboard ID. And we'll store this in a local variable again and print out some information about it. So we'll take the response, we'll find the high scores member, we will iterate over this, and for each one of these we'll print a custom message that says user, oops, forgot I should name my Lambda member event. Scored event dot scored. Okay, let's run this one final time and see what we get. Okay, so this time we created a new leaderboard with the ID leaderboard-1. Now we're finding two leaderboards, the original one we created and the newest one we created. And then for that newest one, it's showing us the scores that have been posted. This is just kind of a quick, simple, almost trivial demo of how you could use a generated client in your own application and a little bit of the features that Smithy Kotlin provides in the way of syntax and conventions. So with that, I'm going to switch back over to the demo, or to the slides. And we're going to talk a little bit about the future. So Smithy Kotlin's code base consists of kind of two main parts. One is the generated code that we were browsing to in Aaron's part of the demo, and it's unique for every model. It's custom, like generated each time, and it varies from model to model. But the important thing is that it's generated into the common source set using only pure Kotlin code and no particular JVM APIs or anything like that. The other part of Smithy Kotlin is the core runtime. This is a static set of code that does not change from model to model. It contains some of our primitives like authorization types and the HTTP engine, stuff like that. Unfortunately, right now, it's written only to work on the JVM and Android. But we did build Smithy Kotlin to be multi-platform from day one. We simply haven't added additional targets to it yet. We're actively working on adding support for Kotlin native, including iOS, macOS, Linux, and Windows. And we're also keeping an eye on the newer Kotlin multi-platform targets like WASM to find out where Smithy Kotlin could add value. Also, we spent most of today talking about generating code in client-side libraries and the kinds of code that deals with our concerns around creating Kotlin idiomatic data types for Smithy structures, handling serialization and deserialization, creating paginators or retries or stuff like that. And that's a pretty well-defined and well-supported use case for Smithy Kotlin right now. But as we saw in some of the intro slides, Smithy itself is not used just for client-side code gen, it's also for server-side code gen. Services need some of the same code generated for them that clients do, including those same idiomatic data types, serialization and deserialization, but they also have several unique concerns that are different from clients, such as routing incoming requests to business logic handlers, performing validation on input to make sure that it conforms to the constraints specified by the model, and so forth. Server-side code generation is already available today in the Smithy code generators for Rust, TypeScript, and Scala, and we're eager to add support for Kotlin as well. And then finally, because this is Kotlin Conf, we've spent almost the entire day talking about just Kotlin, but as I alluded to just a moment ago, there are Smithy generators for other languages. Currently, we have well-supported, well-used generators for TypeScript, for Rust, for Scala, and for Go. We're also actively working on adding support for Swift, Java, Ruby, and Python, and we're keeping an eye on other languages and ecosystems, how they're being used to see where Smithy could provide additional value. So taken all together, the future of Smithy and Kotlin looks pretty bright to me. We've got goals for expanding the types of platforms that we support, the kinds of targets that we use, the kinds of languages that we are available in, and then additional use cases like server-side code gen. The roadmap for how and when these things get developed is strongly influenced by user feedback, users like you all. And so at this point, hopefully you're asking yourself, how do I get started, or how do I give some of that feedback? Well, first thing to do is to check us out on GitHub. Up here are the QR code links for the Smithy repository, the Smithy Kotlin code generator, and then all the code from today's demo in case you want to play with a sample project. Then after that, come to our repos and create issues, start discussions on our discussion boards, send us pull requests even if you think you can help contribute and make Smithy Kotlin better. Just let us know what features you want to see or what bugs are preventing you from getting your work done the way you want to. Because again, that user feedback is really valuable in helping us prioritize our roadmap. And then finally, let us know if you build something cool. We always really enjoy hearing what people are building with our open source products. So come brag about something. That's our talk. Didn't go exactly as we had planned, but please be sure to vote on this session in your Kotlin Conf app. And with that, we'll open it up for some Q&A.